A very good day to my panels and coordinator. My name is Chair Mohd Uzair, and this is my thesis presentation for my project titled Development of Virtual Reality Application for Visualizing Tourism Hotspot. Here is the basic presentation outline that consists of introduction, problem statement, aim and objectives, scope of study, methodology, results, evaluation, conclusion, and recommendation. The first outline is the introduction. Tourism is one of the fast-growing industries and potentially to influence the living pattern of communities. Tourism consists of activities, services, and industries that deliver a travel experience for travelers that far away from their home. Travel planning is mostly based on map-based information where tourists will consult with the map before beginning their journey. Maps play a significant role in highlighting the attractiveness of the tourism destination in a way that the tourist can discover, learn, and communicate information around the location. However, the use of conventional map is less sufficient due to lack of images for tourists to visualize and understand the location. With the technology advance, tourists can experience and immerse the places by using immersive technologies such as virtual reality. The virtual reality can show a virtual environment that tourists can immerse 3D visual experience. Applying geographic information system and virtual reality, it will help provide spatial awareness for tourists and experience the environment. Moving on to the problem statement, there are various problems which are faced by tourists while traveling through different destinations. The problems that mentioned are lack of paper-based map and movement restriction. Paper-based map shows useful information to tourists, but if the map consists huge amount of information, it affects the cartographic design in terms of map scale. Paper map fully depends on symbols to show important features on the map and can be a problem for tourists if interpreting huge amount of the information. Moreover, information on the fast-growing cities can quickly outdated. Tourist maps are meant to be displayed on electronic mobile device. For the restrict movement issue, currently the world is encountering an unpredicted global crisis, which tourism is one of the industries most affected. With the present situation of the whole country lockdowns and travel bans because of coronavirus, countries across the world are introducing a wide variety of measurements to reduce the impact of the coronavirus. One promising way is through immersive technology experience. Next is the research aim and objectives. The aim of the study is to develop a virtual reality application for tourism which is capable of visualizing environment information and providing spatial awareness to users. The first objective is to perform user requirement analysis and analyze the units of target users from the research questions. The second objective is to develop a virtual reality application for the tourists to visualizing the specific area. The last objective is to evaluate the application with the potential user. Moving on to the scope of study. The study area covers the area in University Technology Malaysia, Johor Bahru. The software that will be used for developing the VR application is Pano 2VR, while Insta360 Studio is used to convert into a suitable format. The hardware used in this research is laptop, which to develop the application. Insta360 camera is to capture 360-degree video of the place of interest in the UTMJB. Smartphone and VR headset are used for implementation and evaluation. The target user of this VR application are tourists who have never visited UTMJB. For the methodology, in this research, system development life cycle is adopted as study approach. The model is divided into 3 phases corresponding to each objective. The user requirement analysis is carried out after the planning phase. The questionnaire is developed and distributed to the public to gain reliable data for better data analysis. The questionnaire is to ensure that user requirements are met in the developing the application. 2 types of questionnaire are used in this research, which is paper-based and web-based. Total of 78 respondents are collected. The result in figure 3 show that tourists are interested in visiting Tasik Ilmu, Recreational Forest, Balai Cerap, Sultan Ismail Mosque, Deer Park, and Dataran UTM. However, the data collection for Dataran UTM and Deer Park was unsuccessfully due to certain circumstances. Deer Park has restricted entry where only authorized personnel are allowed, while the Dataran UTM event was postponed because of unavoidable circumstances. The 2 places will be replaced with Latar Journey and Taman Tropika. The result in figure 4 shows that majority of tourists prefer to view tour in 360 video with sound. In data collection phase, the data collection for developing application are collected using Insta360 One camera. The data has been collected at several locations within the UTM based on the result of the questionnaire. After data collection complete, the data need to be converted using Insta360 Studio software for more suitable format, which is in MP4 format. The data are transferred into Panoto VR software for design and implementation. All the data will be imported into Panoto VR software to add all the necessary functions. Figure 5 shows the sample data of place of interest that tourists wanted to visit in the UTM Johor Bahru. The design phase is the second phase in the methodology. The virtual reality system has 2 sides, which is administrator side and user side. The administrator will upload the content into the server to allow users that connect to the internet network to access the virtual tour. The data is then requested and retrieved from the server tier, then visualized in VR view on the client tier. Next figure shows the system architecture of virtual tour. The architecture shows the operation of the application. Elements that list will be available in the application. The elements are carefully selected to obtain clean user interface on the application. Next is the design user interface. The development of user interface is important part in order for the user to understand the structure of the component. A few elements were highlighted in the stage, such as map display, virtual tower display, controller navigation menu, and overall interactive visualization to make sure it is consistent in every aspect by giving a comfortable sense during visualization. After deciding the functionalities that need to be available on the interface, the arrangement of the component is designed. Figure 8 shows the arrangement of the component that will be displayed in the application. After the design phase, implementation is proceed. In this phase, application programming interface are obtained from the Google Cloud Platform allows developer to incorporate Google Maps into mobile application or web page. The Google API are required in Panoto VR software to display the interactive map in the application. There are several API that will be used in the application, which is Map JavaScript, Map Software Development Kit for Android and iOS, and geocoding. Map JavaScript are used to customize map with its content and imagery display on mobile device and web page. The Map SDK for Android and iOS used to add maps into the application on the smartphone. The geocoding API is used to place or position the markers on the map. Google account is required in order to obtain and use the API keys. After the API key is generated, the key are pasted into the Pano2VR setting to enable the map feature display on the application. The development of the VR application is proceed using the Pano2VR software to produce an interactive tour from 360 video. The data collected from the field is imported into the software. Every function is created to make the virtual tour interactive. After the virtual tour has completely developed, the project will be generated into hypertext markup language revision 5 output. The output will be deployed using integrated web server that available in Pano2VR software. The integrated web server generates internet protocol address that allow the project to open in any browser to visualize the virtual tour. As a result, the virtual tour will be displayed in the smartphone. The virtual tour will be explained in the next video. The table shows the function of each component that available in virtual tour. The navigation menu button is to display a list of hotspot places in the UTMJB. A home button will return to the starting point of the virtual tour. The next and previous button is to move one specific hotspot to another or return to the previous hotspot view. Zoom in and zoom out button indicates the zoom in and zoom out of the virtual tour. The auto rotate function is to automatically rotate around the hotspot. The projection button is to switch different projection view of virtual tour. A gyroscope button is to activate the gyro sensor in a device to measure the angular or rotation movement of the person. The full screen button is to enter full screen mode of virtual tour. For the VR mode button is to toggle VR compatibility view for user to visualize using the phone-based VR headset. The map button used to display mini-map on the screen. And lastly, the map container display a map of each location according to the place of interest. Next is the list of hotspot component and its purposes. The video hotspot is a button to display a video related to the scene. The web link hotspot is a button that leads the user to external source or website that related to the object. Information hotspot is a button to display text information of the object. Scene link hotspot is a button to change different location on the virtual tour. For the interactive map, the interactive maps appears on the top right screen by clicking the map button. The map markers indicates pinpoints of the hotspot around the UTMJB. Interactive map enables to zoom or pan around the map. Selecting the map markers on the interactive map can direct it to a specific place of interest on the UTMJB. The field of view on the map container indicates the current visible view around the tour. A wide angle of field of view shows more details on the tour map markers, while narrow angle of field of view will show less detail and provide limited view that can constrain information. Evaluation is the last phase in the methodology. The virtual tour is evaluated using gray box tests. The function that was developed in the Pano2VR software is tested to make sure it is working properly and fulfills the user requirements. If there is error occur on the functionality, it is required to modify the variable in the software. The test is repeated until all the action in the virtual tour element working properly. The black box test is proceed after the gray box test is complete. The test is carried out by public user for further evaluation. The testing is conducted at the open space of every participant's location. Participants have to run the virtual tour in smartphone and insert to the VR goggles in order to use the application. After testing was done, the questionnaire form are given to evaluate the application. The results were shown in Table 3 and Table 4. The first result of the question 1 in Table 3 shows that 80% agree that the application is easy to use, which does not need high technical knowledge to operating it. The second result is that all of the respondents is comfortable with the arrangement of the function in user interface. The purpose of the third question in the questionnaire was to ensure that the performance of the application runs smoothly. All of the respondents agree that the response time affects their experience in visualizing the virtual tour. The feedback from the respondent mentioned that the application is quite delayed and takes time to load the virtual tour content of each places. This is due to poor internet connection or poor performance on the device. The fourth question shows that 60% agree that the content provided in virtual tour is immersive and interactive. The fifth question, it is more focused on the health and condition of the respondent. 40% of the respondents felt cyber sickness in using the virtual reality headset as the virtual reality Google is not matched with the split screen on the VR mode. The last question in Table 3 was to ensure that the respondent was satisfied with the virtual tour application. A majority state that they are satisfied using the application developed. In Table 4, there are a total of 4 questions given to respondents about the interactive map features that are available in Virtual Tour. In first question, majority of the respondents understand that the function of the map as the feature is almost similar to the Google Street View. In the second question, a total of 80% of the respondents agree that the map increases the spatial awareness of the user. The map marker shows the current location of the respondent in the virtual tour, whereas the field of view shows its current view. The third question, there are 60% of the respondents that are satisfied with the current size of the interactive map, as the size does not disturb the view of the virtual tour. The last question in the Table 4 is to ensure that the availability of an interactive map can bring benefits to the respondents. The majority agree that it is essential to have interactive map in the virtual tour, as it helps to identify the current location in the virtual tour. As for the conclusion, Objective 1 has been achieved in Chapter 3 and 4 in the thesis. The questionnaire has been designed and distributed to identify the requirement in developing the application. The questionnaire are analyzed and obtain the result for the development. The research question in Objective 2 has been answered in Chapter 1 and 3 in thesis. The Partner to VR software is used to develop the application. The user interface and function of the application is designed according to the user requirement analysis. The research question in Objective 3 has been answered in Chapter 3 and Chapter 4. The gray box test is performed to make sure the application works properly, while the black box test is done by public user to obtain the feedbacks. There are several recommendations in the project. The first is to improve video quality. The color of 360 video can be enhanced to make the color more natural and vivid. Unwanted objects on the virtual tour can be removed for better visualization of the area. The second recommendation is to reduce the data size. By reducing the data size, it will improve the loading speed and enhance the user experience in visualizing the virtual tour. This should be done without reducing the quality of the video. Lastly, offline mode is recommended to overcome the unavailability of the internet connection. That's all for my presentation. Thank you.